Hello, I am Mohammad Arman Rahman and my ID is 19101106. Now I am going to show our Proteus part here. First of all, I have taken all the necessary components and connected them accordingly. Then one of my fellow group member coded in Arduino and provided me a hex code which I inputted into the Arduino. Next, into the COM port, I have inputted Arduino's default port rate, which is 9600, and then I selected COM1 for communication. Important things to notice here that our pin 2 is dedicated for the data, and that's why it's connected to data pin of TXT11. Also, we know that TXTs are always connected with RXT, that's why I have taken TXT from both Arduino and COM port and connected them with RXT. Now, if I run the simulations, we can see the data on the display here. So this was my part. Now my fellow group member Nafisa will discuss her work on coding part. Thank you.
My name is Nafisa Nawar. My student ID is 18201145. I'm going to give an overview of the data logger coding part, that is the .ino file. This file mainly takes humidity and temperature as input from DHT11 sensor and display on the screen. DHT pin 2 and DHT11 sensor are connected to Arduino. This part of the code will tell Arduino to get ready to exchange messages with the serial monitor at a data rate of 9600 bits per second. Here, these three variables are being used to store the floating point values of humidity, temperature in Celsius and temperature in Fahrenheit respectively. If the sensor fails to read, this part will show the failed to read message. If no errors are found, it will print temperature and humidity. Before compiling the code, we need to go to the preferences and check the compilation option. After being compiled, the code will generate a .hex file, which I will be sharing with my group member. Now, the UI part will be discussed by Fatin.
Thank you, Nafisa. Hello, I'm Patin Sharp. My ID is 21301716. I'm going to describe the UI part or the lab view part of our project. So this is the temperature meter. Here we can get the reading of the temperature from the Proteus, and this is the humidity. We can get the reading from the Proteus, and this is the graphical representation of these meters. This is for temperature, this is for humidity, and this is the table, so that we can see visible the result more correctly. And this is the visual, so here we can get the compost, so that we can connect Proteus with lab view. So I get it from this numeric temperature and meter, and from graph this is the chart, and from table this is the table. So here is the coding part or block diagram part of our project. So here is the table, here is the resource name, here is the temperature meter and humidity meter, and here is the temperature waveform chart and humidity. It is for humidity. So we need to clear the buffer first. I get it from here instrument with and this is here, and this of the part we can get from here. And here is everything we need. So after clearing the buffer, we need to open this, and after opening, we need to read. So we have two inputs, one is temperature, one is humidity. So we need two reading blocks. So here is the input coming, loop iteration. So we'll connect with this counter, and after that, we need to process it and cancel the finishing part, and it will handle the error. So we have a timer here so that we can make a delay of 500 milliseconds after each reading. So this makes the digital value to the string so that we can take it into the table. So this is the string and this is the string. It gets the value and make it string, and we connect it with the table 3 and 4. Here this is for 3, this is for 4. After the string, we connect one reading with the temperature and one with the humidity, and one will get the temperature chart and one will get the humidity chart. This is the timestamp. This one will make the date and one will make the time, and this is connected with the first element and the second element. And this is our ID, and this is the table control. Here we get the string values, and this is the entire table control. We put it in the loop so that we can run again and again. So we need to create this loop condition false so that it will continue until it is stopped. So here is the part. If we play, we can see that it is running as there is no value till now. So it gives 0 and it gives 0. We can see the graph is running perfectly and all values are 0. So there is nothing, and the program is running perfectly. So there is no error in the coding part. Now Sanjita will describe the port parts, connect the Proteus and the lab view part, and show the total project of our total project. Thank you.
Hello everyone, this is Sangeeta. Now I'm going to explain the latter part of the data logger system. We have already seen the block diagram of the system. Now for the front panel part, here we have a thermometer to measure out the temperature and the gauge to measure humidity. We also have two webform viewers to monitor the fluctuations in the values of temperature and humidity, and a table to record all the information and show to represent the values as tabular data. Now for the first part, we are going to connect our Proteus and LabVIEW with the help of virtual serial code driver. We have to make sure that we are connecting our Proteus with compose 1 and our LabVIEW in compose 2. Now if we try to run simulation for both of them, here Proteus, you can see that it's showing the values, and if we run the values in our LabVIEW, here we can see all the values of temperature and humidity are recorded in the table, and we also can change see the fluctuation in the waveform viewer. Now if we want to change the values of the humidity and temperature, we can change it with the help of DHT11. here. Let's say we change the value and run the simulation again. You can see the change value in our virtual terminal and the change value in our T-Boost. And we also got the fluctuation in our web viewer. So that is all about our data logger system. Thank you so much for watching.